My name is Yusuf, and my partner's name is Ahmed, and our project is called Solar Flair. Our main focus of the project here is to determine how much the environment can be impacted and how much money can be saved by installing solar panels on the roof of a given address. So we did this using the platform called DAIN, which is still not completely public, but it was given to us for this hackathon. So we're going to start here by adding our tunnel. So we're going to go to services and add our tunnel here. This tunnel goes to our service that we developed. We're going to select it here so that our agent is what's being used. And now we're going to ask a question. We're going to say how much electricity can this certain address here produce. So we put that in here, set it in. Now it's going to go to some tasks that we developed, that we coded up, given using the DAIN syntax and documentation. And essentially, we're getting here. This uses open maps or Mapbox, sorry, to find the exact house that we're talking about here. It's going to use Gemini to determine a solar suitability score, roof area, what kind of shingles will be best. Sorry, I'll go back here. Sun exposure, shading, and optimal panel kit. And of course, this is using the map data with Gemini. I'll give you an example here. So it says sun exposure, 3 out of 10. Why do you think it's 3 out of 10 just by looking at this? Well, actually, if you zoom out, you'll see that there's a giant mountain over here that's actually doing a lot of blocking. So, and of course, it also tells us what kind of slope that we need for our roof. We're also getting a lot of electricity information here and usable roof area over here. Of course, if you go to our financial data that's given to our UI here, we also have a recommended solar system, size, panel type, which is monocrystalline, a type of material, how many panels we should have, the wattage, panel efficiency, annual production, installation type, and battery storage. This is all generated by Gemini based on the house that we have and the image data that we have. Now, of course, we also have projected monthly production here. Of course, you see in the summer, it's going to be higher because that's when the sun is out more. Now, what have we asked in terms of emergencies, right? There could be emergencies that happen. We want to know, how do the solar and battery systems provide emergency resilience? How do they help us if there's an emergency with power? This is a big problem, especially if there are wildfires, just like they're having in Los Angeles recently. And so we also have a task on our agent for that. So over here we have this query asking how they can be used in the case of an emergency. So not only are we getting our device breakdowns of how much power they draw, but we're getting the storm resilience, the fire resilience, and historical data based on outages that have happened in the past. And of course, we're also seeing the power draws of critical devices. So this is important data for us to have for emergencies because this can help us navigate situations like the recent Los Angeles wildfires. So using GenAI, we have this financial analysis that comes up here that tells us our system cost, incentives and rebates, net cost, annual savings, payback period, ROI, 20-year savings, and the financing option that we may have. And over here we have a graph that tells us the savings that we'll have over time. So of course at first it'll be negative because we have to pay for the solar panels, right? But after 13 years or so, $1,000 savings. After 24 years, we'll have $22,000 of savings. So we're getting these things produced by the Gemini API. And when we ask for further financial analysis here, we're seeing how much CO2 that we're actually reducing, right? And we're seeing, like, what does that mean, right? Well, first of all, this is the estimated monthly projected production here. We're also seeing our solar system will offset over 7,000 kilograms of CO2 annually. This is equivalent to planting 340 trees or taking 2 cars off of the road. So we're kind of putting it in a more perspective that's more easy for us to understand. Thank you for listening to our presentation. We'll be around in the hall, and feel free to reach out if you have any questions. Thank you.